Let's talk about graph patterns and queries. We've talked a lot about building OWL models and how to populate them with instance data. What we are going to talk about next is how to retrieve information from such a model. So we talked about a triple before, a triple being a subject, a predicate, and an object. And this pattern, we're expressing it in this particular syntax with the subject, predicate, object in angle brackets, because this is one of the syntaxes that is specified in the Sparkle recommendation of the W3C, the Graph Query Language Sparkle. We're going to use this syntax for all of our queries except when they're in saddle syntax. So it turns out a triple pattern can be used to query a knowledge graph simply by matching the pattern with the graph. So for example, suppose a triple is completely specified as in Mary, child, John. We can treat this as a query, it is a proposition, and therefore it's either true or false. If it's in the knowledge base, then as a query it returns true. If it's not in the knowledge base, then the proposition is false or the query returns false. However, a triple can be partially specified. Suppose that we said Mary, child, and instead of specifying an exact value, we put in a variable, an unbound variable O. And the syntax in our query, in the W3C query language, is a question mark variable name, so question mark O. So this query basically means find all of the object values of triples with subject Mary and predicate child. So we have an unbound variable O, and we're looking for all bindings in the knowledge base for which this triple would be true. We might have more than one unbound variable in our triple pattern. So for example, if we said Mary question P question O, then we're saying find all of the predicates and their object values of triples with subject Mary. Or in fact, we could have a completely unspecified pattern, question X, question P, question O, and this query means find all of the triples in the knowledge base. So this concept of a triple pattern, either fully specified or partially specified or not specified at all, gives us a way of querying a knowledge base. However, it's a simplistic way of querying the knowledge base. We can only look for single triples or triples matching a single pattern, but we can use variables to link multiple triple patterns together and enable more complex queries. So for example, I might have the query Mary, child, question X, and then a separate pattern, question X, friend, question Y. So in this case, question X and question Y represent the unbound variables X and Y, and X will be bound to each triple, the object of each triple with Mary as subject and child as predicate. And then for each value of X, Y will be bound to each to the object value of each triple that has a binding of X as subject and friend as predicate. The dot in between the triple patterns simply separates the patterns, and if you're reading the triple, you can read it as AND. Nor do the triple patterns have to start out with things that are specified and end with things that aren't. Suppose I said question X, child, question Y, friend John. This query would mean find everyone who has a child who has a friend John, or I should say has the friend John, he being a specific individual. The select keyword in front of such a query allows us to specify which values to return. So for example, if we said select question X, question Y, where, question X, child, question Y, friend John, then we're saying we'll return the parent and the child for each child that has a friend John. But if I were to say simply select question X, where, and the same set of conditions, then that would say just return the parents who have children who have friend John. So I can specify which variables, and in fact, like SQL, I can use an asterisk to say return everything, return all of the variables that are in the patterns. There are a couple of additional concepts that are important to graph query languages. One is filters, the other is optional patterns. So graph patterns are insufficient as a query language. Patterns only allow exact matches in the knowledge graph. Filters enable refinement of those results. A filter is applied after the graph patterns are matched to reduce the result set. So for example, suppose I said select question P, question G, where question P is type person, question P has age question G, but now I add a filter on question G. Filter question G greater or equal to 18. In other words, find all persons and their age who have age 18 or older. So again, we match all of the patterns excluding the filter, find all of the triples that fit this pattern. We can get all of the people and all of the ages, and then we're going to filter them so that we only return the values for which question G, the age, is greater than or equal to 18. Another important concept is that of an optional pattern. This is important if we have sparse data, if our data is not from a tabular point of view, if you will, completely specified. So we might say select question P, question G, question Y, where question P, type person, question P, gender G, and then optional, question P, date of birth, question Y. So if I queried my instance data from the previous exercise, I would get John Adams as a male, and this is his date of birth. I would also get John Adams Sr. as a male, and no date of birth is known, but rather than exclude this triple because it doesn't match, I get a null in my tabular result because there is no value. So the World Wide Web Consortium, W3C, has a standard for the Sparkle query language. And Sparkle supports many other constructs beyond what we just discussed. Here are links in the slides to documentations, and here's a nice little summary cheat sheet about Sparkle capability and constructs. The Jena Reasoner in Saddle uses the Jena ARQ Sparkle query engine, so it processes Sparkle queries. Note also that the Saddle grammar supports Sparkle queries as opaque strings. So I can say ask, colon, that's a keyword construct in the controlled English. And then inside of quotes, I can put a Sparkle query. In this case, there is limited error checking of the query before the execution. So it's largely an opaque string. We do some error checking, and the parser will do runtime error checking, but there's not complete error checking. The Saddle grammar itself supports simple queries as Saddle query expressions. So I can say ask colon, again the keyword for a question, a query, and then in the Saddle grammar, controlled English, I can say select P, comma G. Note here that there's no question mark and the variables are comma separated. So it's a list of variables where P is a person and P has gender G. And I could also put filters in here. But if I have complex query expressions, then I will need to drop into Sparkle. When I use the Saddle grammar for queries, the concepts are semantically colored. They're linked to the knowledge graph definitions and other references. and these queries are translated to and executed as Sparkle using the same Sparkle engine, Sparkle query engine. We have only talked about select queries. Besides select, Sparkle supports ask, and ask actually is what is used if we are in the category of fully specified query pattern. So I would say ask, and then I would expect the keyword ask. Ask Mary Child John would return true or false. Oops. Construct queries, which generate graphs by querying this graph, another graph is generated. Describe queries, and update queries, where update includes delete data and insert data. And these references will give you documentation to these different kinds of Sparkle queries. But again, the Saddle Query Grammar supports only simple queries, but they can be of all of these types, excluding describe. Okay, an exercise on queries. Create the following queries in your genealogy instance data model. Find all spouses. Secondly, find all instances of person, and if known, their gender, date of birth, location of birth, and spouse. And third, find for each person their parents, if they are known. In this exercise, our task is to add some queries. And the first query that we're going to add is to find all spouses. So in Saddle, the keyword for query is ask, followed by a colon. And this is a simple query, so we can use the Saddle grammar. We can say select S1, S2, where S1 has spouse S2. And we'll save this. And now I'm with my cursor with this editing window highlighted. I'll go over here either to the Saddle drop-down menu or to this icon, and I'll select Test Model. As a result, I get that there are 3 matches, that Elizabeth Quincy has spouse William Smith, that John Adams Sr. has spouse Susanna Boylston, and that John Adams has spouse Abigail Smith. This is only going to pull out the explicit spouse connections that we have put into the model. So we put in one here, and John Adams, Abigail, we have that. And we have a spouse relationship here, we pulled that one, and here, so we pulled that one. So those are the only matches that we have. Our second query question is to find all instances of person, and if known, their gender, date of birth, location of birth, and spouse. So again, we're going to do an ask. We're going to use a Sparkle query in this case. So we want to select, and we want to know the person. So I'm going to call that variable question P. Their gender, I'll call that question G. Their date of birth, and so I can just call that, maybe I'll call that Y for date of birth. And the location of birth, maybe we'll call that LB. And the spouse, and maybe we'll call the spouse S. So those are the things we want to pull back. So this is going to be where, and then we'll get into the patterns that we want to match. So we want question P to be of RDF type person. And I'm going to wrap down here. And then actually it says optional for all the others. So we're going to say optional, and it doesn't really have to be uppercase. question P, gender, question G. And we need to close the curly brackets. And we also have optional that question P as date of birth, question Y, and I notice I have an extra caret up here I need to get rid of. We'll close the curly brackets for that optional. And then we have optional, and again we have question B. So now we want to get a birth and has a baby. Question P, and that birth has a location. Question LB for location of birth. And that location, I'm sorry, I want a question L for location. And that location has, maybe I need to rethink my variables here. Let's see, we want the person, we want their gender, we want their date of birth, the location of birth, and their spouse. So we're going to get a location, and the location is going to have a description, and we're going to call that our location of birth. Maybe I should call it LD for location description. That might make more sense. And that's the end of that optional. And then we have one more curly bracket to close the where clause, and a double quote to close the quotation marks, and a period. So let's see what's wrong here. Let's see, we are description not found. Okay, I misspelled description. There is some checking. Okay, so it's a little harder with Sparkle queries to know whether your syntax is correct. So now I could comment out this query if I don't want to repeat it, and a control / will comment something out. Then if I save the model, then I should be ready to execute this new query. Okay, I have a syntax error in the query. Let's see what we have. So right after the LD, close colon, close colon, and we're expecting something more. So let's see here. So this curly bracket matches that one, this curly bracket matches that one, this curly bracket matches that one, and this curly bracket matches that one. So, oh, I got a comma in here. That's where that was next to the this location. Well, I'm not sure that I can quite make sense out of the Jena ARQ query engine parser's error. But anyway, let's try it one more time. And we'll test the model. And this time we get results back. We get John Adams, gender male. The date of birth is, and we actually get back the day of the week. Lovely. October 30th. 1735, Braintree, Massachusetts. And the last thing we're going to pull back is a spouse. but we don't actually explicitly have, or maybe I didn't put in spouse. I didn't put in spouse. No wonder we didn't get back spouse. So let's try that again. We wanted spouse to be the last thing. Fine, we can make spouse the last thing. So we'll do optional question P, spouse, question S. We'll save that. We'll clear our console window. We'll try this one more time. And we have an error because we're missing the last closing curly bracket. So we'll save that, try again. You can see that sometimes takes a little effort. And even though I have optional wrapped around all of these patterns, it turns out that they all exist in the knowledge base. And you might ask why only John Adams is returned. And actually it's the same reason as in the previous case. If you look through this, John Adams is the only one who explicitly meets the first condition, which is that P is of type person. So that's why we only got back John Adams. And finally, our last query is to find each person and their parents if known. So we're going to do an ask again, and we're going to select some person, and we're going to select their parent, which we'll call PNT for parent. So we're going to set up our conditions. So we're going to say that question P is an RDF type person. That's our first condition. And we're going to interpret that as saying their parents, if known. We'll say that this is optional. We don't have to make that uppercase. Optional question P as parent, question PNT. So that would give us one set of answers. And another way that we'll get some answers here is to say that optionally we have some birth, question B, which has baby, question P. So we want to find the birth in which this person is the baby. And then from that birth, we want to find the mother, who will also be a parent, question PN. So there closes that optional, that closes the where, and we ought to be good to go. Once we close the double quotes. So I'm going to uncomment this query. I'm going to be optimistic here. Clear my console window, and then run all of the tests and see where we are. So if I double click on that, I can make it full screen. We've got our first selection of spouses. We've explained that. We have our selection of the person and their gender and so on and so forth. We've explained that. And then we have this selection of person and their parents if known. So we have John Adams has parent John Adams Sr. and John Adams has parent Susanna Boylston. So let's look at this. So John Adams has parents here. So that works. So let's comment out this piece of information that Susanna Boylston is his parent, and see if we can pick this up from the fact that John Adams that we have a birth here with John Adams with mother Susanna Boylston. And actually, if I do that, I need to say a woman because I haven't yet defined Susanna Boylston. Now I have. So now we specified one parent directly, and the other parent we should be able to pick up because we're querying this birth of John Adams. So let's run our query one more time and see what we get. And you'll observe we only picked up this one. So we might ask why that is. Well, it's a little simplistic to think that I can combine these in exactly the simplistic way. This brings up another construct which we need, which is that of a union of results. So I want to combine a couple of things. So I want to pick up where P is type person, and then actually what I want to do is I want to have this optional parent thing here, and I actually want to put that as one operand of a union statement. And so what I'm going to end up with here is I'm going to take this person P and I'm going to take all of the values of parent and I'm going to do a union of those with all of the values that come from the mother of a birth of that person. So let me balance my parentheses here. Those balance. I have one more. So I'm going to put in the one more that balances there, and then that should be valid. I'll save that, clear this one more time, and let's test the model. And now we do, in fact, pick up both parents, one from this explicit parent statement and one from this birth with a mother. So this illustrates that queries, you can combine results with a union, but you have to, you can't be completely naive about it.